feedback to Unit 1 Atomic Structure Assignment. So the first question is about an isotope with 74 protons, 109 neutrons. What is it? So its atomic number is the same as its proton number, so 74. Its mass number is the protons plus neutrons, that's 74 plus 109 equals 183. And its chemical symbol can be worked out by how many protons it has. So its proton number is 74, therefore is W, which is tungsten. So the next question is about one similarity and one difference between those carbon isotopes. They have the same atomic number, therefore the same number of protons. And the next question, then it asks about difference. It's about the fact that there's a different number of neutrons in each of those isotopes, and I've listed how many neutrons they have. Their mass number, take their proton number, gives their neutron number. The next questions explain why the three isotopes have the same chemical properties. Is because they have the same number of electrons. That's the key word, although you can also include protons as well, but you must include same number of electrons in your answer. The next question is about completing the table with relative masses and relative charges. So the neutron is 1 relative mass and relative charge is 0, neutron neutral. The electron is -1 charge and the relative mass is 1 over 1800 for the electron. This may differ from different texts, anywhere between 1 over 1800 to 1 over 2000, but you can't say 0. Next question, you need to work out what the atom is from the description. So the element has twice as many protons, which makes it 8 protons. That makes it therefore oxygen, because oxygen has 8 protons. You then need to work out the mass number, which is 17. The way you do that, beryllium has 5 neutrons. The element in question has 4 more neutrons, makes 9 neutrons altogether. So the mass number is 9 neutrons plus 8 protons makes 17, and that's where you get the 17 from. The next question is about phosphorus, and it's working out the new ion here. It's a single positive ion, hence 1 plus, and the phosphorus neutrons, the protons, there are 2 fewer protons, so that's -2 makes 13 protons, therefore aluminium. Work out the number of neutrons for phosphorus, 31, take 15, gives you 60 neutrons for phosphorus. A new element has 2 fewer neutrons, so 16 take 2 makes 14. The missing number here is the mass number, which is the neutrons plus the protons gives you 27, so the final answer is 27 Al+. And the number of electrons in Al+, well, it's got 1 fewer electrons because it's a 1 plus charge than it should have if it were the neutral atom, so 13 take 1 equals 12. For A, you need to work out the electron configurations for different atoms. The first one was the phosphorus atom, which is in period 3, it's in group 5, so it's a P block, and it's 1s2, 2s2, 2p6, 3s2, 3p3. Phosphorus has a total of 15 electrons, and you can check that by adding up the superscript numbers. They equal 15. Next is germanium, which is period 4, group 4, P block. It has a total of 32 electrons. So it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Although it's 4th period, it's 3d10, and then 4p2 because it's in group 4, so it's 2 along the P block, hence 4p2. Na plus, it's the Na atom, but it's lost. It's 3s1 electron, so it's 1s2, 2s2, 2p6, and the last one of the set there is sulfide, S2-, well, it should be 3p4, but you add 2 electrons because it's a 2- charge, so it becomes 3p6, and there is the full electron configuration shown. Explain why germanium is classified as a p block element. It's because its outermost electron is found in a p orbital. The next question is about polonium, a difficult question. This one, you start with the shorthand configuration of xenon, and then you look at the 7th period, and you'll see that it's 6s2, followed by 5d10, but also don't forget there's 4f14 as well. The lanthanide series, there's 14 atoms there, so you mustn't forget the 4f14, tricky question. And then finally polonium is the 4th element along in the 6p, so 6p4. D, another difficult question. You needed to work out which element had 4 electrons in its outer shell with 5 shells of electrons. Well, the 5th period is the one with starting rubidium over to xenon, and the element with 4 electrons in its outer shell is actually tin. It's 5s2, 5p2. It also has those 4d10 electrons as well, but obviously 4d is not on the outer shell. It's the 5 electrons which are on the outer shell. Last question is about relative atomic masses and isotopes. So in this question you needed to say talk about what can you deduce about the relative abundance of the 2 isotopes of bromine 79 and 81. And you can say one of 2 things. You can either say 79Br is a little bit more abundant than 81 because the average is slightly closer to 79, or you can say approximately the same abundances. In the next question you need to estimate the relative atomic mass of rhenium to 1dp and explain how you arrived at your answer. Well, anywhere between in the range of 186.1 to 186.5 obtained the first mark, and then you need to state that the RAM is closer to 187 than 185 because the 187 Re isotope is more abundant. Now, how you get there, if you struggle to work that out, you can actually do a calculation like this, shown with the percentage times by the isotope mass for each isotope and then divide by 100. That gives you 186.3. However, the way to go about this with just by estimation is that you've got 37% of the 185 and 63% of the 187, so the relative atomic mass is going to be closer to the 187. Then you need, in the last question, work out the RAM for the element X, and you need to multiply the percentage by the isotope mass for each case, and then divide by 100 because it's a percentage, so they add up to 100, or in this case actually 100.01, which gives you an answer of 28.1, and you needed to quote it to 1dp and locate the element with the RAM closest to 28.1, which was silicon, for that final mark.